Section 5.3, Rules and Fallacies, and these are rules and fallacies as they pertain to syllogisms, okay? Categorical syllogisms. Remember, we're not just talking about categorical propositions now, but categorical syllogisms. And you remember I said earlier, once you have a syllogism in standard form, there are three ways you can test to see if the syllogistic argument is valid or invalid. Mood and figure. And we did that last time. If you can see the mood and figure on either of those two lists, you remember here's the list right here. If you have mood and figure that you can see on this list or on a certain condition on Aristotle's list, if you see it on either of these two lists, you can call the syllogism valid. If it's on Aristotle's list, you can say from the Aristotelian standpoint. You can make that caveat. So we had mood and figure, and then I mentioned you can do it through Venn diagrams, and we'll do Venn diagrams. It'll be the next video, and I'll show you how that works. But I'm going to give you the second method here that I'm going to go over in that order. So the second method I'm going to introduce is rules and fallacies for categorical syllogisms, okay? Valid syllogisms, let me read this here, will conform to certain rules. If any one of these rules is violated, a specific formal fallacy is committed, and accordingly the syllogism is invalid. Conversely, if none of the rules are broken, the syllogism is valid. Now we're going to consider 5 rules, but let me repeat that. When you have a syllogism, you are going to use this like an algorithm. Start with rule 1, start with rule 2, 3, 4, and then 5. If you have a syllogism and it violates none of these rules, the syllogism is valid. But for it to be valid, it has to pass all 5 rules. It can't violate any of them, okay? So if it doesn't violate any of them, it's valid. But for the syllogism to be invalid, all you have to do is find just one rule it could violate, though it can violate more than one rule. Okay, so you get that? For it to be valid, it can't violate any of them. For it to be invalid, all you have to do is find just one. But you can't have more than one. If it violates one of the rules, it's not valid. Okay, so let's go over these rules here. And the first two, Rule 1 and Rule 2, what I'm going to do here is give you some of the theory behind it, and then when we do Rule 3, 4, and 5, I won't bother with the concept behind it. I just want to let you know that there are reasons logicians have discovered that these rules have to be obeyed if a syllogism is going to be valid. And there are reasons logicians know that if this rule is violated, it shows that the chain of logical reasoning, there's a serious break or disconnect where those premises, because this rule has been violated, something in the inferential chain gets broken and it's an invalid syllogism. You cannot conclude with 100% certainty the conclusion. Okay, let's go Rule 1. And you notice up here what I drew was A, E, I, and O. You know, that's A, proposition, E, I, and O. And what I did is what I circled, the red circle means this term is distributed. This is just a distribution cheat sheet up here, because you're going to need to know what terms are distributed. So it's good to have this thing handy when you're doing the rules and syllogisms, okay? So here's the thing. If you find your syllogism is valid because you have found it on either of the two lists of mood and figure, let's say the syllogism you look at, you find the mood and figure here or here, provided it meets Aristotle's condition, so you know it's valid. That same syllogism, if it is valid, you should have it be able to pass all 5 tests and not violate one of them. So these tests, mood and figure, syllogistic rules and fallacies, and Venn diagrams, if something's valid, it should be shown to be valid by mood and figure, the rules that we're going over now, and by the Venn diagram. There should be consistency all the way across. Okay, so rule 1, let's say we're given this syllogism right here. All sharks are fish, all salmon are fish, therefore all salmon are sharks. Rule 1 says the middle term must be distributed in at least one premise. If this syllogism violated Rule 1, and I said name the fallacy, you would say it's committing the fallacy of undistributed middle. Okay, so I will explain this here a little bit more. First, let's find the middle term. The middle term is fish, right? Fish appears once in each premise, but you don't see fish in the conclusion, so we know this is the middle term, right? And what this is saying is, once you know what the middle term is, it has to be distributed in at least one premise. So, all sharks are fish and all salmon are fish. You notice these are A propositions, right? Well, if you look at the A proposition, is the predicate term distributed? And up here, it's not circled. The subject term is, but the predicate term is not. So right here, the middle term fish is not distributed, and the second one, the middle term fish for the minor premise, is not distributed. So this syllogism would be invalid because, you remember, all we have to do is find one rule it violates, and your reason, and you can find more than one rule it violates, but let's say this was the only rule, you would say invalid fallacy of undistributed middle. Now you may want to know the concept here. I told you I'd share that. It's because of this, okay? Let's say you have a big circle and this is fish, right? So we put fish in there, and then this says all sharks are fish. So this would be sharks, okay? And then it says all salmon are fish. So we'll put salmon over here. Okay, that's salmon. Here I'll kind of just say salmon and shark, so you can see that. Here's why it's invalid. Sharks is distributed, meaning it's talking about all sharks, but fish, the class of fish, is not. This is saying sharks are included in fish. It's just a part, a little part, a part of the wider class of fish. So shark just takes up a little part here. And salmon, fish is undistributed. It means only a part of the fish class is referred to. Salmon only take up a little part. So that's why salmon and shark can be in different parts. If fish was referring to all of fish, salmon and fish would take up the whole area. But all it's saying is just a part of the fish class is being taken care of, right? And just a part of the fish class is being taken care of for the salmon and for the shark. So you don't know that all salmon are shark, because shark could be in a different part of fish and salmon could be in a different part of fish. So you don't know that all salmon are shark because fish is undistributed. The fish class, not all of it is being talked about, just parts, and if you can only occupy a part, you don't have to be occupying the same part. Therefore, you don't know for certain that all salmon are shark, and by this diagram, here it's possible shark and salmon can be completely different, right? They are different. Here's a little wall between them, but they still are fish. So that's kind of the concept behind that. Okay, let's go to Rule 2. If a term is distributed in the conclusion, then it must be distributed in a premise. I underline if. If you don't have a term in the conclusion that is distributed, you don't have to worry. Rule 2 cannot be violated. So if you have one term that's distributed, that term has to be distributed in a premise. If you have both terms in the conclusion distributed, both terms have to be distributed in the premise. Okay, in the premises. So here's an example. So the key thing is if. So let's look at this one. Some dogs are not mammals. Okay, so this is a O statement. And if we went back up to the top here, let's go back up. The O right there, the predicate term is distributed. Okay, so we come back down, and right here, some dogs are not animals. Animals is distributed. So animals has to be distributed up here. So if animals is distributed in the conclusion, You find where it is, and it has to be distributed here. But this is an A proposition. And with the A proposition, let's go up here. The predicate term is not distributed, and animals is in the predicate term. Animals is not distributed. So this violates this rule. This syllogism here is not valid, and if this was the only one we'd find in terms of a rule being violated, you'd say invalid the fallacy of illicit major, and the reason it's illicit major is animals in the conclusion is the major term. It's distributed in the conclusion. It is not distributed in the premise where it appears, the major premise. So that's why you say illicit major, because we're dealing with the major term. And we go to the next one. It's the same thing, but illicit minor is, we look at the conclusion. All animals are tigers, A statement. Animals is distributed here. So we need to find animals where it appears in the premise right there. But that is an A proposition. Animals is in the predicate position, and we know going up for the A proposition, the predicate position, you don't see a red circle, it is not distributed. And since we are dealing with the subject term of the conclusion, that's the minor term, so it's called illicit minor. Okay? So that's how that rule works. Rule 3, 2 negative premises are not allowed. Okay, so this is easy. You just look here. Oh, you know what? I told you I'd get you the theory behind this. So let's talk a little bit about the theory. The reason you have to have, if a term is distributed in the conclusion, it has to be distributed in the premise is this. You remember with deductive arguments, the conclusion cannot contain more info than what is contained in the premises. Contained in the premises. Okay, you remember a deductive argument, the conclusion can never go beyond the premises. Inductive arguments, they can. So this should make a lot of sense now. So your conclusion is referring to all members. You have a term that all members, you remember if it's distributed, it's talking about all members of that class, but the premise, if it's undistributed, not about all members. So what's happening here is you're getting more information in the premises that were there in the beginning from, you're getting more information in the conclusion from a term than there was information that was provided for that term in the premise. Okay? So a premise having that term, and then when you jump to the conclusion, suddenly you have more information. You cannot do that. It has to be no more than what's given in the premise. Okay? So that's what's going on. If you have a conclusion distributed, you got all, but the premise, it wasn't talking about all. Where did the extra come in? You can't shove this stuff in. You only get in the conclusion what you get from the premise. Okay? So that's the kind of the theory behind that. Now for the premise, the rules coming up now, I'm not going to talk so much. I'm not going to talk about the theory anymore. We'll just go through the rules. I just wanted to give you two examples that there is a method to the madness. These logicians know what they're doing, and these rules, there are deeper reasons why they make sense. Now just trust the rules. Okay, rule 3 is not hard. 2 negative premises are not allowed. Okay? So let's look here. Here's the 2 premises. This one's negative, right? There's the no. And here we have an R naught. So we'll know from this that it has 2 negative premises, so it's invalid. And if this was the only thing it violated, you would say invalid. It commits the fallacy of exclusive premises. Okay, what I'll do, we'll stop here and then we'll go to Rules and Fallacy Part 2. We'll talk about Rule 4 and then spend a little time on the existential fallacy, so I make sure you understand how that works.